we're into some logic. So here's what it's called. It's a very short section, not a lot to it, but let's have a look. Unless I'm on page 62. You can represent a set of elements by listing the elements. For example, A is equal to 6, 7, 8, 9. Using words or a sentence, all integers greater than 5 and less than 10. Using set notation, for example. So the squiggly bracket, so that's important. X such that, that's what that straight line means. We talked about this last year. X such that 5 is less than X is less than 10, where X is an element of the integers. So you'll see this notation. Okay. I suppose there is this one, but we don't use it a whole pile. So this guy has a different, this guy also can be this. I think it's K. We'll see it as we go through it, but it means integers. I gotta check that on the exam. But that means, that symbol means integers. So you've got integers, X is an element of the whole numbers, X is an element of the real numbers, and X is an element of the natural numbers. So just a quick review then. Natural numbers are what numbers? Place those in order from smallest set to biggest set. Actually, let's do that. Can somebody do that?
From smallest to biggest?
From smallest to largest. In terms of the number in each set.
Well, X is an element of all reals.
That's the biggest.
That's the largest.
Oh, yeah, sorry.
So what's the smallest?
Natural.
Natural. Okay, so it looks like this. Natural numbers, and then what?
Integer.
For me?
Real because that's 0.
Real has every number.
Integers or no wholes.
Whole numbers. Okay, so natural numbers 1, 2, 3, 4, 5, 6. Whole numbers 0, 1, 2, 3, 4, 5, 6. And then integers negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Right? And all of these are dealing with non-decimal numbers until you hit the real numbers. And it would look like that. So that's the order. So remember, natural numbers are 1, 2, 3, 4, 5. So all positive numbers over, if you put them as a fraction, be over 1. Okay? And then you got, so your natural, whole, integers, and reals. Okay? You can show how sets and their subsets are related using Venn diagrams. That's what I just did right there. Venn diagrams do not usually show the relative sizes of the sets. Sets are equal if they contain exactly the same elements, even if the elements are listed in different orders. You can indicate the number of elements in set A using this notation. So this guy is a new notation to you as well. N of A asks you how many are in that set. N of A asks how many are in that set. That's what that is, the number in set A. Okay? Not asking you which ones are they. It's asking you how many are in it. And the other notation that you haven't seen, the other notation you haven't seen is this. Equals universe. All of set A, everything not in set A means everything in the universe. Okay? So to show the universe, they use a square for it. So it looks something like this. And then they just put a U in it. And that's just saying that that's everything that's in all the sets and not in all the sets. That's what that is. Okay? So we'll look at an example of this in a second. Are there any questions about this? This is all stuff you should have got in grade 10. So just the notation is a little bit different. Okay, so let's look at an example. Indicate the multiples of 4 and 8 from 1 to 400 inclusive using set notation and noting any subsets. Also represent the sets and subsets in the Venn diagram. Okay. So we have to have all the multiples of 4 and all the multiples of 8 from all the natural numbers 1 to 400. So the universal set for this question is all the natural numbers up to 400. Okay? So 1, 2, 3, all the way to 400, right? But how many of them then? So then to represent, so this would be writing it all up. Okay? So how do I demonstrate it using set notation? So set notation means I'm going to put x such that always start with your smallest value, less than or equal to x, less than or equal to your highest value, 400, and it has to be an element of what? Are we talking decimals?
No, natural number.
For me?
Natural number.
Natural number, exactly. Very good. So I put this in at the end, where x is an element of the natural numbers. Okay, so far? Anybody have a problem with this? Alright, so this is the part that's going to be a little bit difficult today. It's just writing of the set notation. Okay, so for example now, let's talk about all the values. So let's write out all the values that show me the multiples of 4. So what's the first multiple of 4? 4. And then what's the next one? 8, 12, 16, and we go all the way up to, is 400 one of them? Yeah, it is, right? Okay, so far? So how do I write this without writing out all of that? How do I show that? Would that be correct? If I'm explaining the top part of this, x is all of these values, 1 to 400. How do I get the multiples of 4? I take all of these values, correct, and times them by 4. And does that get me all of these values? 4 times 1, 4. 4 times 2, 8. 4 times 3, 12, and so on, correct? So this is how I write it up. Alright? But, here's the thing. How far does it go? Do I multiply it by 400? How high does it go? For this one? 50? What's 50 times 4? 200. So I'm still within. So 100, right? So I go 1 less than x is less than, oops. Less than or equal to? Still not right. Tough morning. 100, where x is an element of the natural numbers. Like I said, this is the hard part. Okay, so now you've seen this part. Go looking in your book. Try and do 8 now. Show me what 8 is going to look like. Start with writing out all of the set notation on the bottom. So go do that right now. Just cover it up so you're not looking at it. Try and write that up. Good so far? Okay, so that's the easy part if you're just to write it out, right? Yeah.
How do you know which letter to like start with?
You can choose whatever you like.
Okay.
So what is it? E such that E is equal to 8x, where less than or equal to x 50, right? Okay, good enough then. Okay, so that's basically all there is to it. All right, you get an opportunity to do that in the top one. Some more notation. Look at page 63. Everybody's okay here? Page 63. So notations. So I need you to have a look at this. First of all, a disjoint set or two disjoint sets means they have nothing in common. That's what disjoint means. There's nothing in common. Okay? I guess that's the bottom thing in your box there. S is a subset of T. So S is a subset of T. Okay? So what that means is that T is the bigger of the sets, and all of the S elements are in T. Okay? Is everybody okay with that notation? Yeah. S is a subset.
Yeah.
So a subset means it's smaller than the set of T. Okay, so T will have more in it. S will be the smaller than T. That's what that means. Okay? Okay. Okay. Turn over to 66 now. Okay. These are the ones that are kind of fun to do. They're solving questions using Venn diagrams. So sets that are not disjoint share common elements. When drawing or looking at a Venn diagram, keep the following in mind. Each region of the diagram represents something different. Each element in a universal set appears only once. An element that occurs in more than one set goes in the region where the set contains the element of overlap. To count the elements in non-disjoint sets, count the elements in each region just once. Okay, so let's look at a question like this. All right, Chantel asked 6 people at a senior citizen's residence what types of movies they liked. The results were shown. She wants to use the data to answer these questions. How many people like mystery or comedy or both? How many people like mystery only or comedy only? Draw a Venn diagram to use to show your data. Okay, so we have 2 movies in this survey, right? 2 movie genres. So what are the 2 movies? One's comedy and what's the other one? Mystery. So mystery and comedy. Okay. So the universal has how many in it? How many people did they ask? 36? And of those 36, how many are in neither of the 2? 6. So that goes on the outside here. Okay, because it's not a part of it. Alright? So the first thing that you do then is you find out how many like one or the other or both. So how many is that? If 6 don't like either, how many is that? 30. Right? That leaves you 30 people that like either mystery or comedy, or they may like both. So how do I find out how many like both? I always start in the middle. Okay? How many like one So how many like mystery?
20,
20, and how many like comedy? And how many does that make?
35.
35, right? But only 30 actually like one or the other or both. So if there's 35, that means then that how many would like both? 5 like both of them. So I put that in the middle right here. So that's where I start. Okay? So if 5 like both, how many like just mystery then? 15. Because there's 20 that like mystery total. And if 5 like both mystery and comedy, that leaves me with 15 that like just mystery. And how many then like just comedy? Find out how many you're working with. And then you add up the other two to find out how many you're over, because that's how many like both. And then you just use the individual. So what actually happens here, and what this is an easy one because it's only 2 circles. We're going to work with 3 circles. You find the middle always. The end. A, N, B, and C. You always find the middle first. And then you work with the individual and ones. So if I'm looking at the order in which I want to go about this business, is like 1, 2, 3, 4. You find all of the ands first, starting with the middle one. Okay? And then from there, you do the ands if you can, then you do the or, and then you do the individual after. Okay? That's how that works. All right, so you're gonna do that in lesson 2, in 3.2. 3.2 is real short. So I will leave it as 3.1 and 3.2 today. And if you do get finished, you can look at 3.3. 3.3 is a little bit longer, and it deals with all of this. Okay?
3.1.
Yeah.
Question 1C. What is the middle part between S and T?
That's what I said earlier. Subset.
Oh, okay.
That means subset. That means S is a subset of T. Okay? Any other questions? Shouldn't be, we haven't started yet, so. Okay. Get the rest of today to work on that.